Hi students, good morning to all. I hope all are fine. Are you studied our previous class? Okay, we discussed about force in our last video. In this video, we are going to discuss about the remaining part of our chapter, force and pressure. I want to ask one question. What do you mean by force? Okay, a push or a pull of an object is known as force. So, we want to discuss about the types of force. What are the types of force? There are two types, contact forces and non-contact forces. In your chapter, there are some examples for contact forces and non-contact forces. Muscular force and friction are examples of contact forces. Magnetic force, electrostatic force and gravitational force are examples of non-contact forces. We are studying more detailed about these forces. Are you ready? First one, contact forces. Can you push or lift a book lying on the table without touching it? Can you lift a bucket of water without holding it? Okay, generally, to apply a force on an object, your body has to be in contact with the object. Okay, in this picture, your hand is contact with what? Bucket. Okay, so the contact may also be with the help of a stick or a piece of rope. When you push an object like a school bag or lift a bucket of water, where does the force comes from? Yes, the force is caused by the action of muscles in our body. The force resulting due to the action of muscles is known as what? Muscular force. The force resulting due to the action of muscles is known as the muscular force. We know that animals also make use of muscular force to carry out their physical activities and other tasks. Animals like bullocks, horses, donkeys and camels are used to perform various tasks for us. In performing these tasks, they use muscular force. Right? Okay, since muscular force can be applied only when it is in contact with an object. Okay, so it is also called a contact force. There is a contact between objects. Okay, are there other type of contact forces? Okay, let us find out. Yes, what is this picture? Recall some of your experiences. A ball rolling along the road or ground gradually slows down and finally comes to rest. Right? Okay, when we stop pedaling a bicycle, what happens? It gradually slows down and finally comes to a stop. And also in the case of a car or a scooter, also comes to rest once its engine is switched off. Right? Similarly, a boat comes to rest if we stop rowing it. Okay, in all these situations, no force appears to be acting on the objects. If we take first example, a ball is rolling on the ground. If there any force appears to be acting on the object? No. Yet their speed gradually decreases and they come to rest after some time. What causes a change in their state of motion? Their state of motion is changed from moving to stop, right? So, could some force be acting on them? Okay, can you guess the direction in which the force must be acting in each case? We could say that the force responsible for changing the state of motion of objects in all these examples. It is the force of friction. What? Force of friction, frictional force. It is the force of friction between the surface of the ball and the ground that brings the moving ball to rest. Okay, in the first case, there is a friction between the ball and the ground. Okay, similarly, friction between water and the boat brings it to stop once you stop rowing. And also in the case of bicycle, it stops due to the frictional force between the ground and the bicycle. Okay, the force of friction always acts on all the moving objects and its direction is always opposite to the direction of motion. Since the force of friction arises due to contact between surfaces, it is also an example of a contact force, right? Okay, so we can say that force of friction very important contact force. The force responsible for changing the state of motion of objects is the force of friction. The force of friction is always acts on all the moving objects. In all moving objects there acts force of friction and its direction is always opposite to the direction of the motion. Okay, what is this direction? It is opposite to the direction of motion of an object. Okay, now we can move to the second forces, non-contact forces. Okay, for this we can...
Well, we all know what magnets are. Bar magnet is an artificial magnet which has this shape. Place an iron nail on the same table at some distance away from the bar magnet. Now move this bar magnet towards the nail like this. Keep moving the magnet slowly, closer and closer to the nail, but make sure not to touch the nail. What did you notice? When the bar magnet was sufficiently close to the nail takes a leap towards the magnet and sticks to it. What does this tell us? This shows that the magnet attracts the nail and the contact is not necessary for this attraction. The magnet pulled the nail towards it even though it was not in contact with the nail. The force that this magnet exerts on the nail is called magnetic force. So contact is not required for the magnetic forces to come into play. We call this force a non-contact force.
Okay students, you have learned in class 6 that like poles of two magnets repel each other and unlike poles attract each other. Right? In this picture we can see that opposite poles attract and also same poles what repel each other. Attraction or repulsion between objects can also be seen as another form of pull or push. Okay, so do you have to bring the magnets in contact for observing the force between them? A magnet can exert a force on another magnet without being in contact with it. Then the force exerted by a magnet is an example of a non-contact force. Okay, so we can say that one example for non-contact force is magnetic force. A magnet can exert a force on another magnet without being in contact with it. The force exerted by a magnet is called what? A magnetic force. Okay. Next one, electrostatic force. Now we can move to one video.
For this activity, we need bits of paper and a balloon. We'll take this balloon and rub it on the hair. And bring it to these bits of paper. As you see, the bits of paper are getting attracted to this balloon. This happens because by rubbing the balloon on the hair, it becomes statically charged and hence it attracts the bits of paper.
From this experiment, we can say that the force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the bodies are not in contact. The electrostatic force therefore is another example of a non-contact force. Okay students, you know that a coins or a pen falls to the ground when it slips off your hand, right? And also the leaves or fruits also fall to the ground when they get detached from the plant. Have you ever wondered why it is so? When the coin is held in your hand, it is at rest. As soon as it is released, what happens? It begins to move downwards. It is clear that the state of motion of the coin undergoes a change. Can this happen without a force acting on it? No. Which is this force? Objects or things fall towards the earth because it pulls them. Earth pulls them. This force is called the force of gravity or just gravity. This is an attractive force. The force of gravity acts on all objects. The force of gravity acts on all of us all the time without our being aware of it. Water begins to flow towards the ground as soon as we open the tap, right? Water in reverse flow downward due to the force of gravity. Okay, gravity is not a property of the earth alone. In fact, every object in the universe, whether small or large, exerts a force on every other object. This force is known as the gravitational force. Okay students, now we are moving to the next part, second part of our chapter, yes, pressure. You have learned in class 7 that strong winds during a storm or a cyclone can blow away even the roof tops, right? In your chapter, wind, cyclones and storms. Okay, you also learned that winds and cyclones are caused by the differences in air pressure. Is there any relation between pressure and force? Let us find out. We can do one experiment. Try to push a nail into a wooden plank by its head. Okay, by its head of the nail. Did you succeed? No. Try now to push the nail by the pointed end. Could you do it this time? Yes. Okay, now we can do another experiment. Try cutting vegetables with a blunt and a sharp knife. Which is easier? Yes, cutting with a sharp knife is easier. Do you get the feeling that the area over which the force is applied? Okay, for example, the pointed end of the nail plays a role in making these tasks easier. Yes, we know that when we using the point end, it is very easy to push. Okay, so we can say that what do you mean by pressure? The force acting on a unit area is called pressure. Pressure is equal to force by area on which it acts. Okay, at this stage we consider only those forces which act perpendicular to the surface on which the pressure is to be computed. So note that the area, this area is in the denominator, right, in the above expression. So the smaller the area, what will be the pressure? Yes, greater will be the pressure. Okay, if the area is smaller, greater will be the pressure. Larger the pressure on a surface for the same force. The area of the pointed end of the nail is much smaller than that of its head, right? The same force therefore produces a pressure sufficient to push the pointed end of the nail into the wooden plank. Okay. Do liquids and gases also exert pressure? Does it also depend on the area on which the force acts? Let us find out. Pressure exerted by liquids and gases. Now we can watch some videos.
A wooden block kept on a table exerts a force on it, and we know that the wooden block is a solid substance. What about liquids? We know that liquids are kept in containers. Do liquids or fluids exert pressure? Yes, they do. They exert pressure on the base and the walls of the container in which they are enclosed. The pressure on the base will be downwards, and on the walls the pressure will be sidewards. We can also derive something interesting if we look at the fluid in terms of layers. Say there's water kept in a plastic container. Let's divide the fluid into 5 equal parts. You can see that the second layer of water is holding the weight of the first layer. Similarly, the third layer is holding the weight of the first as well as the second layer. And the fourth layer is holding the weight of the top 3 layers, and so on and so forth. So clearly, the pressure at the bottommost layer is the maximum. There's even a way you can find this out. Near the topmost layer, make a little hole at the side. You'll see that the water flows out from that hole like this. It doesn't roll along the walls, it flows out at an angle. Now let's make a second hole near the layer under it. You'll see that the water flows out at a wider angle as compared to the earlier case. We continue to make holes in the wall, and we'll notice that the water literally squirts out. This proves that the pressure at the bottom is much more than the pressure at the topmost layer. What about the upward force exerted by a liquid? How do we understand that? We will see that in our next video.
We have already learned liquids and solids exerts pressure. But what about gases? Gases also exerts pressure. Let's see how gases exerts pressure. You can see an inflated balloon in my hand. I had blown this. So the balloon is having excess of air inside it. The air inside the balloon is trying to escape it from it, which means air is applying a force on the surface of the balloon. So we can say that air is exerting a pressure on the surface of the balloon. So students, we have learned that gases also exerts pressure.
From these experiments, we can infer that liquids exerts pressure, right? On the walls of the container. Pressure exerted by water at the bottom of the container depends on the height of its column. Right, as height or depth increases, what happens? Okay, pressure also increases. Liquids exert equal pressure at the same depth. Pressure is equal. Okay, in the case of gases too exerts pressure on the walls of their containers. Next one, atmospheric pressure. What do you mean by atmospheric pressure? The atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as what? Atmospheric pressure.
We are surrounded by air from all the directions. This envelope of air around us is what we call atmosphere. Does air also exert pressure on objects on the earth? In our previous video, we studied that the liquid exerts pressure in all directions. For example, here we have the water in a beaker. Due to gravity, this water is pulled down towards the earth. If we divide this water into different layers, then each layer is being pulled down by the earth. Due to this pull, water exerts downward pressure, and this pressure is uneven throughout. That is, the bottom layer experiences more pressure than the top layer. This is because the weight of water above the bottom layer is more, and the pressure decreases as we go upwards. In fact, we saw that the water exerts pressure in all directions and not only in the downward direction. One more thing that we studied about the liquid pressure is that at any point in a liquid, the pressure is the same in all directions. That is, if I take any point here in this water, the pressure exerted by water here is the same in all the directions. Air also behaves in the same way. Just like water, air is also being pulled down by the Earth's gravitational force. This force applies pressure on the air in the downward direction. The pressure exerted by air is called air pressure or atmospheric pressure.
Okay students, now we are going to discuss about the exercise part of our chapter force and pressure. First question, give 2 examples each of situations in which you push or pull to change the state of motion of objects. So here you can write any 2 examples of push or pull. Okay. So first one, pull situations. Example 2 examples for pull situations. In order to open a drawer, we have to pull it, right? This action changes the state of motion of the drawer. Okay. Its state of motion is changes from rest to moving. Second one, to draw water from the well, the rope is pulled. This action changes the state of motion of the bucket. These are the 2 examples for pull situations. Second one, push situations. A football is pushed by the foot of a player. This action changes the state of motion of the ball. Second one, in order to change the place of the heavy box from one room to another, we have to push it. This action changes the motion of the box. These are the examples for push and pull. Second question, give 2 examples of situations in which applied force causes a change in the shape of an object. It's a very simple question and I also give it in your first video. So you can skip or write the answer. First one, by pressing the clay between the hands, it deforms. Its shape is changes. The shape of a plastic bottle changes by squeezing it. You can write another examples. You can write the balloon. Examples with the balloon also. Then third one, fill in the blanks in the following statement. Okay. First question, to draw water from a well, we have to dash at the rope. Yes, pull. A charged body dash an uncharged body towards it. Yes, attract. C. To move a loaded trolley, we have to dash it. Okay, we have to pull or push it. The north pole of a magnet dash the north pole of another magnet. You know that same poles are repel each other. So, repel the north pole of another magnet. Fourth one, an archer stretches her bow while taking aim at the target. She then releases the arrow, which begins to move towards the target. Based on this information, fill up the gaps in the following statement using the following terms. There are some terms: muscular, contact, non-contact, gravity, friction, shape, attraction. So fill in the blanks with these words. First question, to stretch the bow, the archer applies a force that causes a change in its dash. Yes, shape. Second one, the force applied by the archer to stretch the bow is an example of dash force. Which force? Contact or non-contact or muscular or friction? Okay, muscular force. The type of force responsible for a change in the state of motion of the arrow is an example of a dash force. Which force? Contact force. While the arrow moves towards its target, the forces acting on it are due to dash and that due to dash of air. Which are the forces acting? First of all, gravity, okay, by earth, and that due to dash of air. We know that in the case of all moving object there should be one force. Okay, which is it? Yes, force of friction. So friction of air. Fifth one, in the following situations, identify the agent exerting the force and the object on which it acts. State the effect of the force in each case. First one, squeezing a piece of lemon between the fingers to extract its juice. So identify the agent exerting the force and the object on which it acts. Okay, so we can note first one. We make a muscular force to extract the juice of the lemon by squeezing it, right? As a result, the shape of the lemon gets changed. Second one, taking out paste from a toothpaste tube. Yes, here also we use muscular force, right? To take out paste from the toothpaste or toothpaste tube, we use our muscular force. This muscular force acting on the toothpaste tube leads to a change of its shape. Next one, a rod suspended from a spring while its other end is on a hook fixed to a wall. Okay, here the suspended rod exerts a force on the spring and pushes the spring downwards. As a result, the spring gets stretched, hence its shape gets changed. An athlete making a high jump to clear the bar at a certain height. We know that the feet of the athlete exert the muscular force on the ground, which pushes the ground. This allows him to jump over the bar. As a result, his rate of motion gets changed. Okay, I hope all understand. Next one, a blacksmith hammers a hot piece of iron while making a tool. How does the force due to hammering affect the piece of iron? We know that a blacksmith uses his muscular force while hammering a hot piece of iron. The muscular force changes the shape of the iron so that it can be given the desired shape. Seventh one, an inflated balloon was pressed against a wall after it has been rubbed with a piece of synthetic cloth. It was found that the balloon sticks to the wall. What force might be responsible for the attraction between the balloon and the wall? Okay, we know that there is a charged body and also uncharged body. Force between charged body and uncharged body is known as what? Electrostatic force. So, when an inflated balloon rubbed with a piece of synthetic cloth, it becomes charged. A charged body attracts an uncharged body. When this charged balloon is pressed against the wall, it sticks to the wall. Thus, the electrostatic force acts between the charged balloon and the wall. Next one, eighth one. Name the forces acting on a plastic bucket containing water held above ground level in your hand. Discuss why the forces acting on the bucket do not bring a change in its state of motion. We know that for holding the bucket of water above the ground, we use muscular force. This muscular force acts against the force of gravity. Right? When we pick bucket, what happens? We use a force against force of gravity that pulls the bucket towards the ground. The two forces are equal in magnitude but opposite in direction. Therefore, the net force on the bucket is zero. Hence, there is no change in the state of motion. Ninth one. A rocket has been fired upwards to launch a satellite in its orbit. Name the two forces acting on the rocket immediately after leaving the launching pad. We know that the force of gravity is the one which acts on the rocket to pull it towards the ground, and the other one is the force of friction. We know that all moving objects have force of friction. Okay, force of friction acting on all moving objects. So, the two forces are gravity and force of friction. 10th one. When we press the bulb of a dropper with its nozzle kept in water. Air in the dropper is seen to escape in the form of bubbles. Once we release the pressure of the bulb, water gets filled in the dropper. The rise of water in the dropper is due to dash. Pressure of water, gravity of the earth, shape of rubber bulb, and atmospheric pressure. Due to the atmospheric pressure, there is a rise of water in the dropper. So, D is the answer. Okay, when all the air escapes from the nozzle, the atmospheric pressure which is acting on the water forces the water to fill the nozzle of the dropper. So, atmospheric pressure. Thank you, students.